Welcome back to part 2 of our rules for product to sum and sum to product formulas. We're going to be taking a look at a few examples here. Some you're going to do on your own. We'll bring them back to class tomorrow, see how we did. All right, so the first we're going to take a look at, we want to write these as a sum or difference. So if you notice, we're having cosine of 40 times the cosine of 32 degrees. Well, we want to know how can we write this as a sum. Well, we're going to use our product to sum rule. Product to sum rules. And if you notice, this is cosine cosine. And our rule for cosine cosine says I'm going to write this as 1/2 the cosine. And my rule here says to first subtract the 2. So it's going to be 40 minus 32. And then it's going to be plus the cosine, and then we add them. 40 plus 32 degrees. And we just simplify that out a little bit. We get 1/2. This becomes the cosine of 8 degrees plus the cosine of 72 degrees. And remember, we're finished. Don't be a hero and distribute, because you'll probably make a mistake there somewhere. Everybody does. All right, now, for number 2, it's 2 sine 454 sine of 15 degrees. Now, if you notice, we have this 2 in front of it this time. It really means nothing for us right now. Well, we're just going to multiply our answer by that 2 at the end. But we take a look at these two right here, and they're different angles, and it's sine, sine, and our rule here, if you remember, is the same for cosine. The only difference is in the middle, instead of adding, we must subtract. So this becomes 1/2. This becomes the cosine. Again, subtract them. 54 minus 15 minus this time the cosine, and now we're going to add them together. 54 plus 15. And just simplify. 1/2, this becomes the cosine of 39 degrees minus the cosine of 69 degrees. Now, we're not done yet, because as some of you guys have already pointed on your head, don't forget the 2, don't forget the 2. Yep, don't forget that 2. And those cancel. And what are we left with? The cosine of 39 degrees minus the cosine of 69 degrees. All right, now, for number 2, oh no, radians. Oh no, radians do make it a little bit harder, because we're going to have to add and subtract fractions. But the idea is still the same. Here we have 2 sine of pi over 7, cosine of pi over 3. Don't simplify. Don't simplify. That's not what we're doing here right now. We're just going to use the rules to rewrite this as a sum or difference. So again, the 2 means nothing. If you want to, you can write it off to the side if you want to. Go 2 times something. This is sine cosine. So be careful with sine cosine, which means it's going to be sine, sine, and a plus. You'll see in a second. Hold on.
Ms. Scorsia, if you're in the building, would you come to the front conference room? Ms. Scorsia, to the front conference
This
room.
becomes 1/2. Open up the brackets. We get the sine. The first one says to add them. Pi over 7 plus pi over 3. And this becomes plus. If it was cosine sine, we would make that a minus. The sine of pi over 7 minus pi over 3. Now, using Mr. Wernow's slicker than snot way, we can actually add these pretty quickly. Those 2's cancel. We don't worry about that. We get the sine. My rule, very simple. Multiply the denominators together. Best way to get a common denominator. 21. Cross multiply. I get 3 pi plus 7 pi. Plus, over here, it's the same thing. The sine, and this time we get, instead of adding, we subtract it. 3 pi minus 7 pi over 21. And we just simplify that. Very easy to do. We get 10 pi over 21 plus the sine of negative 4 pi over 21. Now, you are able, if you don't like that negative 4 pi over 21, you are able to rewrite that. Just add 2 pi to it. And what you wind up with is 38 pi over 21. And that's okay to do, or whatever. So just add 2 pi to this, and you'll get the same answer. Okay? But it's okay to leave it as negative if you want. All right, now, number 4, Try this one on your own. It's cosine sine, so it's the same rule as here, except for that becomes a minus. So try that one. All right, let's try the next bunch, okay? Next four. Now we want to express these as a product. We're adding and subtracting here. So this is our sum to product rule, okay? So we're going to, very simple to do this. This is cosine 51 minus cosine of 23. So my rule, it says to use negative 2 sine, and the first thing we're going to do is add them together, 51 plus 23 over 2, and the next one becomes the sine of subtracting them, 51 minus 23 over 2. And that's just our rule. You just got to know that rule right there, okay? Now, the next one, we get negative 2. The sine, just simplify. That becomes 84 over 2. Divide that by 2, you get 37 degrees. Times the sine, subtracting them, that becomes 51 minus 23 is 28. Divide that by 2, we get 14 degrees. And there's our answer. Number 6, now you thought the last one was hard. Gee, wait till you try this one, okay? Because you got a fraction over a fraction. This is sine, and it's a minus. So my rule says 2 cosine. Add them together first. Be careful, this is not very pretty. 17 pi over 12 plus 11 pi over 12 over 2. See, there's my A, there's my B. Times the sine. Now we subtract them. 17 pi over 12 minus 11 pi over 12 over 2. Ugly. But it's not too bad to do. Just go step by step. 2 cosine. If you add these together, that's 28 over 12 over 2. That's 28 pi over 12 all over 2. And it's okay to leave it like this for now. We'll take care of that in just a moment. Times the sine, and if you subtract 17 minus 11, this becomes 6 pi over 12 over 2. Yuck. Now the only thing we don't like, this is considered a complex fraction. So what I'm going to do is I'm going to multiply both top and bottom by the denominator. 12. 12. Because what that's going to do is going to cancel the top here. And what I wind up with is 2 cosine 28 pi over 24. Cancel, cancel. I get the sine of 6 pi over 24. And it's okay to leave your answer like this. You can simplify if you like, but there's no need to. Okay, we just don't want fractions over a fraction. All right, so number 7. Let's take a look at one more together. I'll let you guys do number 8 on your own. Number 7 is the sine of 124 plus the sine of 62. Sine plus sine. So my rule here says to write this as the sine to sine. Add them together. 124 plus 62 over 2. And the cosine, now I subtract them. 124 minus 62 over 2. And what do we wind up with? 2 sine. And this becomes just 93 degrees times the cosine of, well, that's the 62 over 2, which is 31 degrees. And there's our answer. All right, it's a little harder, but I would like you to try number 8 for tomorrow in class. Okay, get that one done for tomorrow. And we're going to take a look at just a couple more examples. I think we're ready to go. All right. Now, number 9, this one is going to have a lot of answers. Welcome to the most answers you'll probably ever get. We want to answer between everything for x is between 0 and 2 pi. Okay? So, if I were to solve this one, this is sine of 4x minus the sine of 2x. So my rule is the sine minus sine, so it's 2 cosine. The rule says to add them together, so I get 6x over 2, and then subtract them. The sine of 2x over 2 equal to 0. And I just simplify this. 2 cosine of 3x sine of x equal to 0. Again, if I divide by 2, those cancel out. So what I'm left with is the cosine of 3x times the sine of x equal to 0. This is what you want. This is how we do it. Now, what makes it hard, though, is remember, we're going to get the cosine of 3x equal to 0, and I'm going to set the sine of x equal to 0. Now, sine is equal to 0 pretty easy. 0, pi, and 2 pi. We don't include 2 pi because normally we stop at 2 pi, you know. Now, where is cosine equal to 0? Well, cosine is equal to 0 at pi over 2, 3 pi over 2. But we have to keep going because remember, we need 3 times around the circle. That's once around the circle. So where do I have to go to? Oh, look, what's next? 1, 3, 5. 5 pi over 2, 7 pi over 2. There's a pattern to it. That's twice around the circle. To get 3 times around the circle, just go another one. 9 pi over 2. And what would be next? Keep adding 2. 11 pi over 2. Very good. And that's 3 times around the circle. Again, the 3x comes from here. Divide everything by 3. Pi over 6. 3 pi over 6 becomes pi over 2. 5 pi over 6. 7 pi over 6. 9 pi over 6 becomes 3 pi over 2, and this becomes 11 pi over 6. Here's your answers. Don't worry about this 2 pi, because you're not going to worry about that one. And there's all of our answers right there. All right, now, last one. Very easy to do. Redo this one if you need to. This is a good one to redo, okay? All right. The next one, we want to prove that this is our proof that the sine of 3x, the sine of x plus the sine of 3x over the cosine of x plus the cosine of 3x equals the tangent of 2x. It's just rewriting them. What are these equal to? Well, the sine of x plus the sine of 3x becomes 2 sine of, add them together, 4x divided by 2 gets 2x, and then we subtract them. The cosine, 1 minus 3 is negative x over 2. So there's our cosine right there. On the bottom, the cosine of x plus the cosine of 3x becomes 2. This becomes the cosine, add them together, divided by 2. 1 plus 3 is 4x over 2 is 2x. Oh, look at that already. You kind of see it right there. And we get the cosine, and again, subtract them. A minus b. 1 minus 3, negative 2. Whoops. Sorry, that's just negative x. Negative 2x over 2, which is just, again, negative x. Sorry, that should be negative x because 1 minus 3 is negative 2 over 2 is just negative x. See if that's equal to the tangent of 2x. Easy, yeah. Those cancel, and the 2's cancel. And what are we left with? The sine of 2x over the cosine of 2x equal to the tangent of 2x. Yeah, and what is sine of cosine? But the tangent of 2x. Proof. Whoops. There we go. Tangent of 2x equals the tangent of 2x. Now down here there's your problem. Down here's an extra credit problem. Use a calculator, see what you can do on it, okay? Maybe add 10 points to your homework tomorrow night. Okay? Good luck. We'll see you guys tomorrow.